Welcome to another episode of Code for Thought. For this second special SeptemberRSE conference episode, I'll be talking to Bradley Tipp from Microsoft. Brad and I talk some time about RSEs and their importance to research. I think he makes quite a compelling point about how the research software engineering community can help close the technical skills gap between scientists and the ever-growing ecosystem of technical solutions that deliver their research results. And here now my conversation with Brad. Hello, Brad, and welcome to the show. Brad, you're in Seattle, so much appreciated that you get up quite early for this. And I would like you to introduce yourself before we start.
So, hi, Peter. I'm Brad Tipp. I work at Microsoft, and as you say, I'm based in Seattle, so I'm 8 hours ahead of you. And I look after our academic research audience, as we would call it here. So essentially my job is to help researchers and RSEs and universities get their research done as best as they can, and maybe we'll talk about what best is a bit later.
In the first part of this discussion today, I would like to talk about research software engineering in general. In the second part, we can talk about what that means in terms of running software, helping researchers write the best software, and also the infrastructure. First of all, research software engineering is actually a fairly new discipline. I think in the UK and in other countries, it's been created sometime around the 2010s. From your perspective in the industry, what does actually bring research software engineering to the table?
I have an advantage in terms of, you can tell from my accent, I'm originally a Brit, and I have a lot of connection with both the universities in the UK and with researchers who have been working on different projects for the last 20 odd years. I think, first of all, this is something that when we saw it emerge in the UK, we really liked and we wanted to support right from the beginning. And I think we have tried to do that. I think we think the role is really key. And I personally, if I could ask government for one thing at the moment, it would be, please invest in this community and invest in these roles. It's been a self-organizing group. In the UK, they've done really well, and there is professional recognition in many respects of how the roles work. But actually that I would like to see the UK really be the exemplar for the rest of the world. We're starting to see places around the world gain momentum, but it's definitely not at the same level it is in the UK. And the reason, so why am I such an advocate of this?
Indeed.
And fundamentally, it's because it's doing one of those great things. It's solving a skills issue. Researchers are entirely focused on doing their research. And historically, if you did research that was computationally heavy, you tended to come from one of the disciplines that had a maths and possibly software background. So your ability to actually kind of digest the computing environment wasn't so difficult. It was still a challenge. Using an on-prem HPC setup is not as easy as everyone would like it to be. But the people who historically have used those setups, at least they kind of came from that background area. They had a good grounding. One of the things that's happened over the last 15, 20 years is that every single researcher in every single discipline is to some extent doing the same thing. They're capturing data, they're storing data, they're analyzing data, and they are displaying that data in some way, visualizations. And most of them, for many of them rather, it's a new thing to not be doing it either on paper with your capture, in Excel to your initial analysis.
Well, they still do.
There's an awful lot of Excel used, that's for sure. And just on their local laptop or on their desktop system, their workstation maybe, to actually do the number crunching. So first of all, the role is key because the need for people who better understand that technology area to work with researchers for whom technology is a secondary consideration, not the primary aim of their research, is growing exponentially. And then the second piece is that the compute capability has grown exponentially. So more people are saying, oh, I need to create this machine learning model. I mean, that is such a new thing for so many domains. And yet I say that, oh, I need to create this machine learning model. And it sounds so normal, so natural. And yet, if you go back only 5, 6, 7 years, for most researchers, they would say, what's that? You could argue the rise of the algorithm is driving a lot of this need. And that's only going in one direction, and it's only happening exponentially. And without these RSE roles and without their capabilities, it doesn't matter how much compute you have available to you, you will not be able to take advantage of it. You'll simply be stuck in this skills gap of your domain expertise may be fantastic, but you don't have the knowledge to take advantage of this, cloud infrastructure that's now broadly available to everyone. So to my mind, it's a crossing the chasm role, and it's absolutely key to the entire research community achieving their aims.
What I'm hearing is that by not supporting RSE roles, we're actually leaving research behind. Is that what you're saying?
Yeah, I think the canonical example I tend to use comes from probably, 6 or 7 years ago, where I came across a researcher who was doing work on Holocaust survivors. And what he was trying to do was to collect all of these images from pre-Second World War of families and individuals. And then he was looking for a way to actually associate the individuals within the images to basically show some of the survivors, hey, you've got relatives that you don't even know about. And this has been an intensely manual process. He worked with a group of people to do image recognition, facial recognition, and then association. And it blew his mind what the system could do. And he was like, there is no way that I and my team could have done in 10 years what this system was able to do in hours. And it wasn't that the system got it right every time, but it gave them insight. This person looks as though they should be related to this person. It gave them a tremendous amount of leads that they could then focus in on. They were historians. They were absolutely as far from people building machine learning models and doing facial recognition as you might imagine. And yet the benefit to them was enormous. And I think as soon as you start to see those kind of examples, then you start to realize they are just everywhere. As I said, it really doesn't matter what you are doing these days. The ability to use that technology for your domain is absolutely a use case. And the only thing that's going to hold you back is, well, I'm not a computer scientist and I'm not a mathematician. So how do I actually apply that knowledge in my domain?
So what as universities do we need to do to change this from your perspective?
Peter, that's a lovely question. And it's lovely because I've spent a lot of time talking with universities. And what I've come to realize is it's not just the universities. As usual, it's a whole ecosystem that needs to evolve. And some of it is evolving. And frankly, some of it is a little slower to evolve. So I think you have to start at the beginning. You have to start by saying software engineering, I'll call it. And that's probably too grand a phrase. It's almost computing as a function. We need to recognize that in the same way that we teach maths and English to everyone in infant, here in the US, middle and high school, in the UK, primary and secondary, we need to start to realize that this is a core competency for everybody. And it needs to be given the same level of investment as those other things. Because frankly, without it, we're turning out people into a world where, yes, they can do mathematics, yes, they can read and write, but they can't use this other language. It is really the critical piece that organizations and they themselves will need as they go through life. Now, I think there's great recognition of this. I think it's also something that the UK has recognized for a long time and is doing a reasonable job of. I still think it needs to accelerate, but I think it's doing a reasonable job of. I think the next stage is as you go into the university space, and it's probably something that the UK finds more challenging because the nature of degrees in the UK are much more focused. Whereas going to college in the US, you tend to start with a broader base.
Mm-hmm.
In fact, you have to do things outside of your major. But I think the UK needs to realise that this element needs to be part of every course. Again, if you're bringing someone in and you're not fundamentally making sure that they can understand the software and systems around their domain, then you're doing them a disservice. And then lastly, I think there's probably two parts. One is the universities themselves need to think about how they invest in this key group. But the challenge for the universities is it's not that they don't see that, it's where is the money coming from? Ultimately, this means that government needs to look at this key role and say, yes, this is something we need to invest in. And this is not a grant proposal. This is actually a function of our education system that if we don't invest in, no one else is going to benefit from. That is a piece that while people in policy and in government are thinking about, I'm not yet seeing the investments coming through. And without that, with all the goodwill in the world from the universities, they just don't have the money to dedicate to advancing this group.
Indeed, at least not all the universities as we would like to see, or not enough universities. So it tends then to happen in particular centres, right? Like the bigger universities like University College in London, and then some universities probably in the US as well, but not across the board and certainly not consistently. It's quite a tall order to actually change all of that because policy, there's a cultural change, how we do education, and then there's a policy change. So how do you think that a company like Microsoft, which has a lot of cloud, can help in this?
That's a good question. It is a big change, actually. I think companies like Microsoft, we can help. We've made an enormous amount of training materials available, and we've provided learning paths for individuals to go down the route of learning about these technologies and being able to use them in free learning situations. I think the problem with that, though, is that works great for the people who are self-identifying and self-motivated to go off and do these things. But it really doesn't work for the broad mass that we need. It's not about including it in every degree. And it still leaves this gap with how do I train a group of people whose job is to help others get their research done using these platforms. I think if I look at the funding requirements, and I'm working with one UK university at the moment on building a model where they would kind of build a new institute to develop these people. The problem is that's a non-trivial amount of money for them.
Yes.
It is also turning out relatively few people over a number of years because training is a time. It takes time. You can't train someone in a month. And the further problem is, and they recognise this, is, it's great that we go off and do this, but the danger is that we go off and do it in a vacuum and we don't recognise that these people are highly valued outside of academia, and that if we invest in this training and we build people who have the capability to help a researcher to build an algorithm or a machine learning model, that industry will reach in and pluck those people out because they have exactly the same requirements, in fact, maybe more so, and they're willing to pay more.
Indeed, so, exactly. It's a retention problem then, isn't it?
Absolutely. Yeah. And so you have to dramatically overfill your pipeline in order to make sure that you're going to have enough people left. Part of the challenge of academia is always that you are taking in a group of undergraduates, you're educating them, and then some of those will go on to be researchers, but the majority of them will go back into some form of industry. So again, this isn't a new problem, but unless you address it at the same scale that you're addressing those fundamental courses at, you're going to end up with, you will end up with the same problem. You won't have enough people to keep your own service going. And this would be a little like saying, pick a department, engineering. We're not really turning out enough engineers, and none of them are going into research. at the university. They're all going off into engineering companies. If that was happening, I think people would very quickly realize that there had to be more investment to do that. I don't know why. I don't know why this isn't recognized as fast. It seems very obvious to most of the people involved. I think it's because it's a new role. Therefore, maybe many of the people who are making the decisions who didn't have experience with this role need to be educated in the change that's happened in the last 10 to 15 years.
It's not only, I think, a new role, it's also a cultural shift away from, as you mentioned quite early on, you do your research and write it down on paper and then you end up in a paper. But nowadays you have the paper as well as the data and probably the software on GitHub or some other repository there you can download it and test it and reproduce. So the whole ecosystem, as you said, has changed quite dramatically. And I think that is a dramatic shift that still needs to filter down because we still have the similar research structures probably in place as we used to.
You hit on a fantastic point, Peter, which is how, what other benefits do you get from this? And, one of the great unspoken realities of research is that very, very little of it is actually reproducible. Even the really good research, if I want to take a paper and think, okay, this is fascinating, let me set up the same experiment to just do nothing more than verify that I get the same result. It's really hard and in some cases impossible. But actually, if you are moving stuff to the cloud platforms, then suddenly you get consistency. If you are using systems that use containerization, then again, you get consistency. And now, not only is it really easy and really fast for me to take an experiment and entirely reproduce its environment and get to, 4 decimal places the same results. What's even more fascinating is I can take your experiment, I can take your data and then substitute my data. I can take your data and substitute my algorithm. And so the ability to actually build on this research is just magnified. I think that is understood, but it's not the implications of it are not being acted upon fast enough. I really think that this is a step change for how a lot of research becomes reproducible and how you can accelerate the kind of research on research mechanism without people having to start again from the beginning.
That's an interesting discussion, and I think we probably could talk about this for quite some time longer. But I would like to move on, since we talked about cloud and cloud infrastructure for quite some time, because we tend to forget that software engineering is not just developing programs and algorithms, it's also actually making sure that we have the environment in which they can run. And you alluded to that a number of times. And of course, Microsoft is one of the providers of cloud services. But at the same time, universities also have on-premise solutions. And they seem to work, sort of UCL, I know, has. So why would they want to change the cloud?
I think it's not that they want to change the cloud straight away. I think it is that for the foreseeable future, it's about providing the right kind of hybrid environment. So why do I need anything more? And it really goes back to the earlier part of our discussion, because more and more and more of the research community has a compute requirement that they didn't in the past. So I think that reason number one, if I look at the amount of compute just a single university is using, it is basically on an exponential curve. And when you're on an exponential curve, you have to look at, wow, this isn't about us building something new. This is about us finding a way to do this in a different way and to do it in a scale way beyond our own organization. The driver is the internal use by the research organization. The second driver, and this is what really makes it exponential, I suppose, is it's not just that more researchers want to use this. It's that each of those researchers is realizing they now have a capability to do things like machine learning, which they didn't in the past. And that provides like a second level of exponentiality to the curve. So it's more people with more understanding that they can do more. And suddenly your on-prem systems are not just stressed, they're 5% of what you need.
Right, they're overstretched, basically.
They're totally overstretched. I mean, it's always been a case that you stand in a queue for most of these resources, which again is not ideal. That was very accepted. Go back 10, 15, 20 years, the idea that you submit a job and at some point in the next day, week or month, depending on where you were
I
and
remember
whatever,
that.
you got some results, at which point you usually realized you'd done something wrong and needed to resubmit and waited a day, a week or a month and got some more results. And that was great because that was your only option. It's a little bit like standing in a queue waiting for a taxi. You just had to stand and wait. There was no other way you were getting home that night. But now we live in the world of Uber and Lyft, where, no, I don't stand in a queue for a taxi. I get my on-demand service. That gets me to where I want to go much faster. I think that's a world that our researchers live in, and they're looking at their research environment and wondering why they don't have the same capability. I mean, that's a separate capability from just the pure scalability. The other piece with the on-prem systems is if you are going to do a very limited, very specific type of research, then an on-prem system is great because you can plan for exactly the amount of compute that you need. It's a closed box, but your box and you built that box to start with. The problem is, especially in the research community, people are not doing similar things. They're doing very dissimilar things. So it makes it very difficult for you to build something that's not just generic, but has 20 different capabilities. Now that gets complicated. The language you're using to write your work, the containerization or other job size that you're using. And that's before you get to the point of saying, well, actually, this group here, their work really should be using GPUs rather than CPUs. And then when you look at what's happened in the last few years with these custom CPUs and GPUs coming out, building an on-premise system for a very specific use case, it's still a good thing to do. But outside of that, why are you doing that is the question. You're forcing your researchers all into a very small box, or what they're doing is they're just going to cloud service providers who say, this box looks a bit closer to the one that I would like. So I think it's a natural evolution as well. It's not a case of shutting down what you do. It's more a case of how do I augment what I already have with these other capabilities?
So how does Azure, I hope I pronounce it right. I'm never quite sure how to pronounce it. Is it Azure or is it Azure or is it?
So I'll tell you a bit of my history. I was in Las Vegas when RSE actually did the very first announcement for Azure.
And, there you have it, Azure.
Well, so let me tell you, Ray stood up and said Azure, and then the very next speaker, he said Azure. And the pair of them looked at each other, and all the marketing people looked at each other and were like, oh my God, we have this word that is pronounced differently all over the world. And there was this sudden panic of, should we tell people how to pronounce it? And then Ray, being Ray, said, no, as long as we spell it the same, what does it matter? So the answer is, it doesn't matter.
Okay, well, I'm going to call it Azure. But anyway, so it's one of the major cloud solutions. What does it actually bring to the research table then? So could you give some examples?
It brings probably too many things to the research table. Like all of the cloud service providers, it doesn't matter whether you're speaking to me or my colleagues from Amazon or my colleagues from Google. We're bringing different things for different people. So at the base level, you're bringing the ability just to take a compute environment, to have some kind of virtual machine, and to make it very easy to parallelize the amount of compute that you have. For a researcher who's currently using their laptop or desktop system and really wants 10 of them, that's a very easy proposition. In Azure, we have systems like Azure Batch, to make it really simple for people to say, I have this job, I'd like to run 100 of them at the same time. There is then base storage and the ability to store terabytes and petabytes of data, whether that's in very cold storage where you have to wait to get it back, or whether that's in highly available, always on, always backed up. That's again one of the other pieces that cloud services bring. As a researcher, one of the things I worry about is, what if my system goes bang? What if there's a pandemic and I can't get into my building to access this thing that's sat on a desk? Very real problem. My example used to be Canterbury University in New Zealand, who had an earthquake and couldn't get into their buildings for many months. But now we have a global example. One of the things it brings, though, is universal access. So any cloud service I can get to from not just any point on Earth. Azure is actually used by the International Space Station as well to do its research. So we actually have a downlink mechanism to enable those guys sitting up there to bounce data down, compute, and then bounce the results back. So anywhere on and even off Earth, you get it.
Okay.
And then the biggest thing it brings environments to the research community at various different levels to enable them to go much deeper. At the high end, things like cognitive services, where I can start to tap into pre-built AI services that I don't have to build myself. I may be using those services to build something deeper or more fundamental myself, but I don't have to start from scratch. I was talking to a research organization and they were flying aeroplanes over crop fields, taking photographs, and then looking at the photographs to determine did they need to do something to these crops, like feed them, or were they infected with insects, so they needed to use insecticide or do something else. And so I'm listening to these guys talk, and I immediately asked them, so are you using our cognitive service to do that? And they looked at me like, no, that's our research project, is to build one. I said, you do know that us and Amazon and Google all have services that you can just pass images to, train the images. And so we spent half an hour rejigging their research project. I think, again, it shows, many of the things that people would have built as a research project are now available almost as an API. And sometimes people feel that's a threat, but actually it's just an opportunity. It's just lowered the bar on the next level that you can go to as a researcher.
But that opens quite a challenge, actually, for researchers and universities, because, as you mentioned, there's Azure and AWS and Google and Oracle and other providers. How do you navigate that? Because, they all have their cloud services. They all have their way of ramping up infrastructure. They all have their portfolio of services.
They do. And I think the answer is some good RSEs. And this is another function that the RSE plays. How do you keep up with this? It's pretty hard for someone who is dedicated to doing that. If dedicated to my research, there is no way that I can understand the capabilities of these cloud service providers. We are literally releasing services, each of us, on a daily basis. So there is no way for a researcher to keep up. This is why this RSE function is so critical, because you have to be able to go to some trusted people in your organization and say, this is what I'm trying to do. What's the best way for me to do that today? Is there one that is offering something that would really accelerate what I'm doing? There are plenty of low-level things where, frankly, whichever one of us you chose, you would be fine. And there are probably fewer where making a choice to use one over the other would give you a significant change. But having people who can help you and advise you on that, and who can spend their time understanding, evaluating, and keeping up with those cloud service providers is really key. If you don't do that, to your point, there's no way you can keep up with us.
Indeed, which brings us a little bit back to the skill gap, because the RSEs may be trained software engineers, they may not be trained cloud engineers. How do cloud companies then fare in educating them up?
Amazon and Google and Microsoft in particular have put a lot of work into building learning platforms. For Microsoft, it's a platform we call MS Learn, and we have some specific training paths or learning paths on there, actually aimed at RSEs in our case and aimed at researchers. I think we're all trying to do that. That's kind of step one. It's still more of how do we come together to do this? One of the good experiences I've had is working with Internet2 in the US, who've built a program called Class. And classes are really about trying to address this skills gap. Part of their role is to help their members, all the universities, build the skills that they need. And so we worked with them on this class program to build a set of fundamental cloud capabilities and then some deeper level connections to capabilities within each of the cloud service providers. Here are some things you need to understand about the difference between on-prem and cloud. Get yourself to a particular level and then go down the particular cloud service provider's learning paths to go deeper into a particular area. So that's something I've seen in the US. I would love to see that repeated in the UK. The more people we can bring in to this problem, the more we're likely to have it solved. And if each piece only solves 5%, but we get 20 players, we'll solve the whole thing. We're trying to do our best, but we will never, as large a company as we are, education is an enormous field. We are just not going to be capable of doing all the skilling for everyone. We have to be part of that community, which we're trying to do, but we also have to encourage the community to self-build.
We're coming to the end now, and there's one question pertaining to the SeptemberRSE conference that you're sponsoring, that Microsoft is sponsoring. So what are you trying to get out of that conference?
For me personally, it's actually probably two or three things. One, it's supporting the community, which is the reason why we sponsor. You know, right from the beginning, we've sponsored this, we've been involved. It's really important for us to continue to support the community at the base level. The second piece is education, where we can, working to make sure that things are available to the community so that the community can keep advancing. And then for me personally, it's actually an opportunity to listen to some of those sessions and to hear, ideally, what we're getting wrong or what the gaps still are. The only way that I can get feedback on what we need to change and what we need to improve is when people tell me. And actually, they tend to tell me more when they're in a forum of themselves talking to each other. The people are terribly polite sometimes when you're talking one-on-one, and they don't tell you what's wrong and they don't tell you what they need to fix. But when they're talking amongst themselves and you are allowed to listen in on that process, you can get an enormous amount of insight. So for me personally, the conference is just a great way to hear what's broken, what still needs fixing, and to try and figure out how I can help in that process.
Well, thanks very much for that exciting conversation, Brad, and I wish you all the best for the future.
Thank you very much, Peter. It's been lovely talking to you this morning.